The Sun, our nearest star, is a celestial powerhouse. It bathes our planet in light and warmth, sustaining life as we know it. But the Sun is also capable of unleashing bursts of energy that can have significant impacts on Earth. These bursts, known as solar flares, are sudden and intense releases of energy from the Sun's surface. Imagine a colossal explosion on the surface of the Sun, a sudden release of energy equivalent to billions of atomic bombs detonating simultaneously. These flares are not just abstract astronomical events, they have the potential to disrupt our technology-dependent world. From communication systems to power grids, solar flares can interfere with the very infrastructure we rely on daily. Solar flares, like many astronomical phenomena, are categorized based on their intensity. The most powerful category of solar flares is the X-class. These flares are capable of releasing immense amounts of energy, equivalent to billions of atomic bombs. Within the X-class, flares are further categorized by a numerical value, with higher numbers indicating greater intensity. An X2.2- class solar flare falls into the stronger end of the spectrum. These flares are significant events, capable of causing noticeable disruptions on Earth, particularly to our communication systems and power grids. This energy is released in the form of electromagnetic radiation, including X-rays and extreme ultraviolet radiation, which travel at the speed of light and reach Earth in a matter of minutes. An X2.2- class solar flare is a powerful reminder of the Sun's energy and the need for continued research and monitoring of our nearest star. Solar flares, especially those in the powerful X-class like an X2.2- class flare, can have significant and wide-ranging impacts on Earth's technological infrastructure. The energy released during these events interacts with Earth's atmosphere and magnetic field, leading to a cascade of effects that can disrupt our daily lives. One of the most immediate and noticeable impacts of solar flares is on communication systems. The X-rays and extreme ultraviolet radiation from flares can ionize the Earth's upper atmosphere, particularly a layer known as the ionosphere. This ionization disrupts the propagation of radio waves, leading to radio blackouts, especially in the high-frequency range used for long-distance communication. Beyond radio communications, solar flares can also affect satellite operations. The intense radiation from flares can interfere with satellite electronics, potentially causing damage or even complete failure. Perhaps the most concerning impact of solar flares is their potential to disrupt power grids. While solar flares can cause disruptions to our technological systems, they also produce breathtaking celestial displays known as auroras. These shimmering curtains of light, typically seen in high-latitude regions, are a captivating reminder of the Sun's influence on our planet. Auroras, also known as the northern lights in the northern hemisphere and the southern lights in the southern hemisphere, occur when charged particles from the Sun collide with atoms in Earth's upper atmosphere. These collisions excite the atoms, causing them to emit light at various wavelengths, creating the vibrant colors that dance across the night sky. Solar flares, particularly those accompanied by coronal mass ejections, can significantly enhance auroral displays. The increased influx of charged particles during these events intensifies the auroras, making them brighter and more widespread. In some cases, auroras can be seen at lower latitudes than usual, offering a rare and spectacular sight for those living closer to the equator. The constantly shifting patterns and colors of auroras make them a mesmerizing and awe-inspiring natural phenomenon. As our reliance on technology grows, so too does the importance of understanding and mitigating the potential impacts of solar flares. Scientists are constantly working to improve our ability to predict these events and develop strategies to protect our vulnerable infrastructure. One of the key organizations involved in space weather forecasting is the National Oceanic and Atmospheric Administration's Space Weather Prediction Center. The SWPC monitors the Sun 24/7, using a network of ground-based observatories and satellites to track solar activity and issue alerts about potential space weather events, including solar flares. Predicting solar flares, however, remains a challenging task. While scientists can identify active regions on the Sun that are more likely to produce flares, the exact timing and intensity of these events are difficult to pinpoint. Despite the challenges in prediction, there are measures that can be taken to mitigate the impact of solar flares. Power grid operators, for example, can implement procedures to reduce the risk of geomagnetically induced currents, such as lowering the voltage on transmission lines or temporarily taking sections of the grid offline during a solar storm. The study of solar flares goes beyond simply understanding a fascinating astronomical phenomenon. It has direct implications for our technological society and is crucial for safeguarding our infrastructure and way of life in an increasingly interconnected world. As we become more reliant on technology, the potential impacts of solar flares on our communication systems, power grids, and satellite networks become increasingly significant. A major solar storm could disrupt global communications, cripple financial transactions, and potentially plunge entire regions into darkness. Beyond the immediate impacts, studying solar flares also helps us understand the sun's long-term behavior and its influence on Earth's climate. Solar activity follows an 11-year cycle, with periods of increased activity marked by more frequent and intense solar flares. Understanding these cycles and their potential effects on Earth's climate is crucial for making informed decisions about our future. The sun serves as a natural laboratory for studying these phenomena on a grand scale, allowing scientists to test and refine our understanding of the universe's fundamental forces. The sun, our nearest star, is a source of both life-giving energy and potential disruption. Solar flares, particularly those in the powerful X-class like an X2.2- class flare, serve as a reminder of the sun's immense power and its ability to influence events on Earth. While solar flares can pose risks to our technology-dependent society, they also offer a glimpse into the awe-inspiring forces at play in the universe. The study of these events is crucial for protecting our infrastructure, understanding our star, and unraveling the mysteries of the cosmos. As we continue to explore and learn from the sun, we gain a deeper appreciation for its role in our solar system and its impact on our planet.